In the last one, we have put together all the concepts of durative actions, causal dependencies, universal quantifiers, objects, numeric fluence, etc. Now, what is left to do from the interesting ways of describing hello world or modeling hello world is modeling with so-called continuous effects. So the challenge here is to describe more truthfully the biology of a human body. If you want to speak, you need to have enough breath in your lungs. So let's start modeling, and we will do that from absolute zero. So hello and hello world and domain hello world. We will not be using types. We will use some predicates and functions, but let's get them declared as we go. So we will still have an action, durative action hello, and it will take some amount of time. We will say that this is well, name length of that person. So let's parameterize that with a person. We will use types. And now the interesting thing will happen. So what is this? Typing is missing and durative actions is missing, as well as the declared predicate. Let's populate these as we go. So let's declare an object hello world, and world is a person, let's say. Now the duration, the name length of world is say 5. Yes, and we want to add hello to world. So that will be our predicate. That will be made true in as an effect here. Set hello person. Let's go simple here. So declared automatically like that. And with just one more requirement missing, let's try that. Let's say hello world. The duration is 5. All right, so we can say hello, but we didn't start caring about having enough air in lungs. So let's so it's more concise. So if we start talking, before we start talking, we should check. In fact, there is more than enough air in lungs than name length person. If it takes 5 seconds to say world, we should have at least 5 seconds worth of air in our lungs. So our undeclared function air in lungs should be here. And before we forget, air in lungs should be initialized to something. And let's try that. If we actually say we have plenty, 10 seconds worth of air in lungs, we still get the plan. And if we don't have enough, let's say just 1 second, then no plan can be found for that. Perfect. So let's put that back to 10. Now, if we actually, let's put it back to 1. If we are in the situation that we do not have enough air in lungs, we shall breathe in, obviously, right? So durative action breathe in has a duration of, well, of how long, right? So that depends. If we have many different people to greet, then you only will breathe in for as long as you're gonna need. So let's actually say that duration could be anything greater than equal to 0. So the planner gets to decide how long it should be inhaling. And that's a duration inequality that we are exploiting here. So let's declare it. So now let's wipe all of this and say, all right, well, while, and notice I'm not going to use the at start nor at end. I'm going to say straight increase as long as we are breathing in. So breathe, the air in lungs will be increasing by a factor of, say, 3 units of time. We can breathe in 3 times faster than it takes to exhale it, because you are pronouncing the name as you do that. And now the opposite, air in lungs, will be decreasing, but let's say will be decreasing just at the same speed as time goes. So inhaling is faster, exhaling and pronouncing name is slower. So let's see how that would work. And indeed, we get an interesting thing going on here. We are breathing in and we are exhaling at the same time. So that overlap, of course, is something that we've seen before. How did we solve it before? We declared a predicate for it. At start, not busy. Busy as in the diaphragm is busy. Negative condition and busy declared. At start busy. At end not busy. And we need to do the same for the hello action. At start not busy, and at start effect and start busy, at end not busy. It would be nice to have some kind of a shortcut for that, right? So will that just correctly modify? Yes. So we breathe in for this much, and we are going to exhale and say hello, and that takes this much. Now, we said that at start, we need to have that much air in lungs, and that happens to kind of exactly work. But in fact, what we should have done is specify this as an overall condition that we never run out of air while we are speaking, right? Well, technically it comes down to the same thing. Still, we can see the same plan, but it's slightly more kind of elegant with the overall condition like that, just in case air in lungs could be modified by some other thing. All right, very well. As we breathe in, there's probably some kind of a capacity of lungs that should not be exceeded. So you would put it as an overall condition of breathing in, and that would give it the kind of upper bound on how long you could be breathing in. And let's try to exploit the fact that we are not declaring that. So what if we have another person to greet, and universe takes 8 seconds to greet, and we want to, for all, greet everyone. Try greeting everyone. Name length universe. You're right. I shouldn't specify the same numeric value more than once. And now you can see that we breathe in for 13 seconds and then we greet 2 people in a row like that. This is where it's not going to be very comfortable. So if we say that overall the air in lungs should be less than lungs capacity, declaring lungs capacity and declaring lungs capacity equal to 10. We should really, let's see a bit more details here. I was expecting a plan. So no plan can be found. And when no plan can be found, let's look at it in the search tree like that. So what can we do? We can start saying hello universe, or we can start saying hello universe and hello world. There is nothing, the breathing in is not actually applicable apparently. So what's wrong here? You're not busy, or air in lungs is greater. Well, that's wrong. I made it the other way around. Should be air in lungs should be less than the lungs capacity. Congratulations to those that caught the error and were shouting at the YouTube channel that I'm stupid. You were right. So here is it, and we can incidentally see it on the search tree that we are breathing in for some amount of time, just enough to say hello world, and then we are breathing in for longer because universe has a longer name to say hello universe. Perfect. So let's go back to where we were and do just one more modification here. Well, could you really be greeting someone if these were some, say, really people located somewhere? You perhaps should first check that they can hear you, that the person can hear. And if they cannot hear, because I'm not specifying in the initial state that they can, there better be some action to durative action, walk closer to, let's say that takes, yes, 1 unit of time, why not? Person, and we could really be describing this in terms of how far it really is. But let's say at start they here, and at end they can hear. So we now have an action to walk closer to the person that can hear us. And now you can see the effect of the heuristic forward chaining search, figuring out that the actions are needed. Incidentally, it might actually be interesting to see that in this search tree, it is, oh, sorry, it was already running. in which order these actions end up being interesting to the planner. The initial state, and you can see two search trees here because the underlying planner here tries to use a hill climb, more aggressive algorithm first, and then failing that will, because we end in a state which where we cannot solve the LPE or otherwise end up in a dead end. We see that we need to walk closer to the universe, and we could walk closer to the world as well. So these are the candidate or helpful actions, and then we can also start breathing in. So if we start walking to someone, then the best thing to do next is to walk closer and finish the walking. So that's one weakness, obviously, that we should not be walking at start and at end not walking while at start we are walking, right? So now we will not be walking to two different people at the same time. Thank you. It was a bit too fast. So now we are not walking to the two people at the same time. And can we walk while we are speaking? Well, we better not be walking to someone when we are speaking to someone else. So this is busy breathing, and we perhaps need a busy speaking to be able to distinguish that. So not at end and at start. Effect is that we are busy speaking. So now we have two kinds of logs, and let's see what that does. It makes us breathe in, walk, and now I can't see the effect of that. So I will make the walking longer, let's say at least 3, so I can't finish walking to the two people. Yes, we breathe in for, that's interesting. Let's actually see the plan for that. We breathe in for 10 units of time because we needed to walk for that long. So you see how the duration of the breathing in now got kind of inflated by that necessity to walk at the same time and finish walking before we start speaking. So did I miss the overall not speaking? Yes. Let's not use the search tree now. It's not that helpful. We are breathing in, then walking. Now we walk to someone else. So we would really want to say that the other person cannot hear us. So let's try that so that we don't walk to universe and then walk away from universe. So let's say that at the end of saying hello, no, that doesn't help. Let's try it this way. As soon as we start walking, all the other persons implying that I need an effect, but that's a condition. Now I can't really do that. So we walk. How would we do that? To, in the simplest possible way, model that we walk closer to someone and then we, at the same time, we walk away from someone else. Now, what if the art effect already of O is that all people not can hear P2. So we basically delete that nice effect of walking closer to someone. I guess it makes me write it the other way around, does it? Yes. So let's try that. There we go. We walk closer to the universe and then greet universe, then breathe in. But while we are breathing in, we can be walking closer to someone else, to the world, and then saying hello to the world. And I guess if we do ask for multiple plans, let me do it here with the command line planner. Let's see if we can get rid of the other walk, because obviously planner is short-sighted here, doesn't see that if it walks somewhere else, yeah, you're losing the benefit. There we go. So we are now correctly with that second plan, breathing in and walking. It's sort of inflated here, the amount of time we are breathing in. So we take the maximum amount of air, actually, interestingly, and then we use a lot of it to greet the universe. We're down here, then we breathe in and walk, and then say hello world. All right, so I managed to dig myself out of the hole, but it is with a combination of derivative actions, two different types of, different instances of locks and semaphore predicates, so that we can do certain things in parallel, like breathing and walking, but we cannot do the other two things in parallel, which is breathing and speaking. So with that, I will stop here, and I'll see you at some future episode of Getting Back to Basics with PDDL. If there are more ways of modeling, say hello, let me know, use the comments. Thank you and have a good year. Yes, you are right, you are right, you are right. There is a much better way of describing with a proper causality explaining model, capturing model, that you are close to the person you are talking to. So let's get rid of this for all effect, which was kind of cool, but quite wrong. In fact, we want to say that while we are talking to someone, so overall, you are close to that person, right? And if you do that, and close to is achieved by the effect of walk, and walk is generalized to walking to but also from having a precondition that you are close to from, you are walking as soon as you start walking. So at start, you are not close to from. At that end, you are close to. In fact, we can delete the can here predicate that no longer actually captures enough, and being close to someone in this sense is actually describing more of the state. We should be getting the plan we want. Except that neither say hello universe nor say world now can be achieved. Why not? Walking, you're never close to anything. So let's actually use another construct here. Let's say that if there are objects that should be in every problem file, we can define them as constants in the domain file instead. So if we start at home, close to, or myself, I'm close to nowhere, and I need to be walking from nowhere to universe or to world. Then initially I am close to nowhere, and then from nowhere I can start walking somewhere. That walk action never had this initial precondition satisfied. So is there any other problem with that? We need to look closer into that one. And to the rescue comes a feature inside this planner where you can run and stop at some more interesting breakpoints inside. And right there, it actually shows more truthfully that there is one of the goals that's not achievable. One of the goals where you are, we're asking to greet everyone, but we didn't care to define how long does it take to greet nowhere. And if you wanted to kind of get convinced why is it, or what actually is happening under the hood, some planners print out the temporal relax planning graph structure layer by layer, so you can see which actions can be applied and how does that augment the reachable space. And you can see that we are walking and we are speaking, but we get as close to saying hello to universe, but then there is a goal that cannot be achieved, which is saying hello to that constant nowhere. So it looked helpful, but not exactly. So for the simpler case here, to keep things simpler, I will just remove it from the goal, and I'll say world and say hello to universe. I will send the planner back to the output window and run it without the reachability graph, and brace for impact. Here we go. We have a plan. Habemus planus. We breathe in and walk at the same time. We say hello to universe, and then breathe in for a little bit and walk to the from universe to world and say hello to world. So this was the other pattern that you may see in many PDDL domains, where we are using a predicate at someone, at something, or close to, and we are maintaining that proximity by protecting it again with a overall condition like that to make sure that we don't start walking away from universe while we are talking to it. Voila, that's the better way of doing it. And again, you saw that, yeah, some ways of declaring the goal might be powerful, yet yes, if the goal is unattainable, then you need the planner to be able to tell you why not. So you know how you need to modify the domain or how differently to generate the problem file. And with that, yes, have a good summer.